In this video, I'm going to show you how to solve exact differential equations. There are two methods to solve exact differential equations. I have written both methods, one in black and one in green. So you have to either follow the blacks or the greens. So I am going to solve one simple example and use both methods. So the first thing is we have to make sure that our differential equation is an exact differential equation. So let's say if our equation is in a differential form of m as a function of x and y dx plus n as a function of x and y dy equal to 0, in order for this equation to be an exact differential equation, the partial derivative of m with respect to y must be equal to the partial derivative of n with respect to x. So this is the condition for our differential equation to be an exact differential equation. So let's now look at one example. Let's look at this example. I had one old differential equation book, so I looked at one example as y squared plus 3 dx plus 2xy minus 4 dy equal to 0. So let's solve this equation. So in order for this equation to be exact, the partial derivative of m with respect to y must be equal to the partial derivative of n with respect to x. So partial derivative of m, in our case m is y squared plus 3, with respect to y will be 2y is equal to partial derivative of n with respect to x, and our n is 2x minus y minus 4, so is equal to 2y. So this is an exact differential equation. So now let's go ahead and use these steps in order to solve. Step number 1 say that find f as a function of x and y equal to the integration of m dx while y is constant. So f as a function of x and y, let that equal to y squared plus 3 dx while y is constant. So this will be equal to x y squared plus 3x now step number 2, write it in this form, f as a function of x and y plus phi y. So let's write this as xy squared plus 3x, which is f as a function of xy plus phi as a function of y. Write it in this form. Step number 3, take the differential of this form with respect to y, the differential of that form with respect to y, and make it equal to n as a function of x and y. So that means step number 3, we take the differential of this with respect to y and make it equal to n as a function of y, which is 2xy minus 4. So from here, we need to compute, we need to find out what phi phi is. That is step number 3. So if we differentiate this will be 2xy plus phi prime as a function of y, we make it equal to 2xy minus 4. So in this equation, of both sides of equation, this will cancel out. So phi prime y will be equal to minus 4. So phi y will be equal to minus 4y. Now, the last step, write it in this form: f as a function x and y plus phi y equal to c, which is arbitrarily constant. So f as a function of x and y, which was x y squared plus 3x plus phi y minus 4y equal to constant. So this is our solution for this differential equation. So let's write that here. That was xy squared plus 3x minus 4y equal to c. So this is our solution. Now, let's use the second method. Let's use the green method. So, step 1 is compute f as a function x and y by integrating the n, which is 2xy minus 4 with respect to y. So if we integrate that, this will be equal to 2x y squared over 2 minus 4y. So this will be equal to 2 and 2 will cancel out, x y squared minus 4y minus 4y. So the step number 2, write it in this form, and step number 3, differentiate it with respect to x. So write it in this form, so that would be x y squared minus 4y plus phi as the function of x, then step number 3, differentiate that with respect to x. So we are going to differentiate this with respect to x and set it equal to m as the function of x1. Set it equal to y squared plus 3. So from here again, now we have to find what is the value for the phi x. So if we differentiate this with respect to x, we are going to have y squared minus 0 plus phi prime x equal to y squared plus 3. So in this equation, from both sides, y squares will cancel out. So we are going to have phi prime equal to 3. So if phi prime of x is 3, so phi will be equal to 3x. So the last step, write it in this form. We already found f as a function of xy, which was that. Which was x y squared minus 4y plus phi x. We find phi x as plus 3x equal to constant. So this is our solution. So if we compare, it's the same. So you can use either way, in order to solve exact differential equations. This was a simple example. If you want me to solve any problem in the exact differential equation, please post your problem under the comments, and as soon as I see a problem posted, I will solve it. So see you all later.